When Blériot first crossed the English Channel in just less than 40 minutes, the time-saving advantages of aircraft over conventional forms of transport became increasingly more apparent. Cities that had previously only been linked by land and sea travel could now be reached in much less time. Soon after the Blériot crossing, the first airliners went into business. Speed was the business, carrying passengers on bumpy rides at speeds in excess of 100 miles per hour to reach their destinations. But gradually, as the airline business expanded, so too did the standard of travel, and the passengers' comfort was improved. Navigation was primitive. The pilot sat outside of the main cabin, following railway lines for direction. But as comfort and speed improved, so too did the aircraft. And by the 1930s, a day's travelling by air could cover distances, such as London to Athens, a journey that would previously have taken 4 days by rail and sea. Piston-driven aircraft by the beginning of the 1950s were now capable of crossing the Atlantic in less than 18 hours. Air travel was now big business, and the world's aircraft manufacturers were working flat out on new designs to cope with the demands of the airline companies, which could carry more passengers even faster. With the rapid development of aircraft, the obvious solution was to build jet-propelled airliners. The new breed of airliners was smooth and sleek. Passengers would now be seated in comfortable air-conditioned cabins, cruising through the air, seemingly motionless. Crossing the Atlantic for the traveller was now no longer 18 hours of noisy propellers pounding the aircraft through bouncing clouds, but 8 hours of smooth, quiet, and comfortable travel. Since the early 1950s, military and civilian aircraft manufacturers had been rapidly discovering the many problems and pitfalls, with aircraft being pushed to ever-increasing speeds, unacceptable stress levels on the wings being one of the most problematic, causing the aircraft to buffet and shake, the pilots experiencing the effects of the controls doing the reverse of what was expected. But the problems were soon overcome, and as jet-propelled aviation progressed at an outstanding rate, so too did the quest for more speed. The race was on to fly at Mach 1, the speed of sound, then to go beyond. To achieve that, an aircraft would have to punch through nature's great obstacle, the sound barrier. This is the pattern sound waves form from a single point, sending out sound waves continuously. If the source of the sound is an aircraft, and the sound waves have enough time to move away from it quicker than the aircraft moves, then the speed of the aircraft is known as subsonic. When the aircraft moves at the speed of sound, the pressure waves can't move away from the source, but fan in a line perpendicular to it. This speed is known as sonic. If the aircraft travels faster than the speed of sound, the pressure waves generated move backwards to form a three-dimensional cone. This speed is known as supersonic. Mach 1 is the speed of sound. Any object traveling faster than Mach 1 creates a shock wave that can cause what is known as the sonic boom. The sonic boom was an inevitable consequence of supersonic flight. Since World War II, tests had been going on throughout the world on wing designs, trying to reduce the amount of drag. There had been much controversy over the choice of the best wing construction, which would enable an aircraft to fly at supersonic speeds. The German scientist Professor Busemann published findings suggesting that swept wings would perform better than straight wings during supersonic flight. The main reason being that the shock waves generated at the nose of the aircraft miss the wingtips if they are swept back. This approach was incorporated into the ME-163 Comet, Germany's rocket-propelled interceptor. Rocket propulsion was available for 8 to 10 minutes, giving this aircraft speeds of over 550 miles per hour. Its swept-back wings allowed flight at high subsonic speeds before the transonic drag took effect. To research flight with a swept winged aircraft, the British design team of the de Havilland Company modified a Vampire. The booms and the tail surface were removed, swept-back wings were fitted, and a swept fin was placed over the rear end of the fuselage. It looked remarkably like the German Comet. Early tests during the war had shown the difficulties of controlling such aircraft when pushing it through high speeds during a dive. Supersonic aircraft would need space for more fuel than the conventional versions. They would also need to be stronger. Swept-back wings allowed for thicker wings able to carry more fuel, more strength, and an even greater reduction in aerodynamic drag. In fact, it was at this period in aircraft development that the whole concept of the wing surface of aircraft was reshaped. As an aircraft flies, it experiences resistance from the air. This is known as the drag. The amount of lift compared to drag that an aircraft experiences at a given speed is a measure of its aerodynamic efficiency. Thin wing sections seem to be the answer with less drag, but the thinner the wing, the less strength it would have. When an aircraft reaches the sound barrier, the air molecules rushing past the wing surfaces in effect become compressed, which, instead of creating lift, forces the nose down. To correct this, the pilot pulls back on the stick, which then creates a great strain on the wings, causing them to flutter. Thin wings under such strain could literally break off. The flying delta wings, which were being tested, were built with much thicker wings, up to 7 feet on the leading edges. For such a design to be able to carry passengers, the wingspan would have had to have been enormous and was therefore going to be impractical. The Vulcan bomber was a delta-winged aircraft, without a tail section, but with a tail fin. During the tests for Concorde, the Vulcan was the aircraft chosen to use as a testbed for the new Olympus engines being designed by Rolls-Royce. A design for a passenger jet, based on a variation of the Vulcan bomber, suggested that it might be possible to fly 15 passengers from London to New York in 3 hours. But to be economically viable for an airline to run such a service, the aircraft would have to be able to carry a much higher payload. Therefore, a better aerodynamic shape would have to be devised. Such a shape did appear with a dramatic impact on the world of aviation in the form of the British Fairy Delta II. On the 10th of March, 1956, Fairey's chief test pilot, Peter Twiss, achieved speeds of 1,132 miles per hour. This aircraft, powered by a Rolls-Royce Avon engine, had a delta wing, no tail section, and a nose section which could be lowered during takeoff and landing. But unlike all of the previous tested designs, this Delta had a thin wing. It was this aircraft which finally convinced the Supersonic Transport Aircraft Committee that such a design could possibly be used to carry passengers. But building a supersonic fighter was one thing. Building a 170-ton airline, which could fly safely at such speeds, was another. By the late 1950s, speed records were constantly being broken. The military now had aircraft which could fly in excess of the sound barrier and far beyond. The USA aerospace industry had both the resources and the ongoing technology to bring this era of speed to life. Not only were they developing aircraft which could fly over Mach 1 and close to Mach 2, But they also were developing aircraft which could fly at speeds in excess of Mach 3. The airframe was designed the same shape as the shock wave it would generate at Mach 3. In this way, the aircraft could take advantage of the compression lift which hampered the earlier designs. This hypersonic aircraft marked the point where it now seemed a foregone conclusion that the same technology could be evolved into airline travel and that supersonic travel would be commonplace within a short period of time. To build an airliner capable of flying through the sound barrier takes an enormous amount of research and development. Every increase in speed costs a massive effort, and for the designers of Concorde, this was to be one of the boldest advances in the history of airline travel, taking some 25 years, occupying some men half of their working lives. The technical breakthrough was well beyond the resources of any one nation. Britain and France joined forces on the project. In 1962, a formal agreement was signed between both nations to bring Concorde into being. This one project committed both nations to Europe's largest technological enterprise. The concept of Concorde took advantage of complex aerodynamics based upon the elegant simplicity of the paper dart, which gives lift and stability at all speeds, ideal for a supersonic airliner. Once, the speed of sound was thought to have been an impassable barrier. Powerful swept-wing fighters had eventually broken through, but getting the 170-ton Concorde to fly faster than the speed of sound was going to be a much taller order. But still, the principle of the paper dart applied. The secret was the thin delta wing successfully used in the Fairy Delta research plane that had broken the world speed record in 1956. Concorde was to travel half as fast again and carry over 100 people. The thin delta produces rolls of air which curl over the wings, giving it a unique stability in all flight conditions. This design of Concorde had to be proved time and time again in practice with small research planes, courting every disaster and aerodynamic problem known to man. Britain started the slow-handling research program with the Hadley Page 115. This design allowed for experimentation with different wing shapes, enabling the designers to compare performances on takeoffs and landings. Another problem that had to be thoroughly tested was the effect of kinetic heating. Produced by flying large aircraft at supersonic speeds, the Bristol 188 was designed especially to carry out this role.
I think that's an interesting thing.
This one piece will make 52 layers.
Watch on mobile devices or the big screen. All for free. No subscription required.
Like Concorde aerodynamics, Concorde materials have had years of testing. In French and British laboratories, thousands of samples have been tried out. Many different kinds of material, aluminium alloys, titanium alloys, stainless steels, were examined. At the Royal Aircraft Establishment, Farnborough, an electron microscope is used to probe into the very elements of complex metals. Only after innumerable checks and tests was the final choice made for Concorde's main structural material, a metal used in aviation for the last 40 years, aluminium. This aluminium alloy, known as RR58 in Britain, AU2GN in France. Special laboratories like this one at Farnborough have devoted thousands of hours to establishing the creep resistance of RR58. Creep is the slow deformation of metal that can be caused by prolonged loading combined with prolonged heat. From these tests, this alloy has emerged triumphantly.
Kinetic heating imposes new demands on aircraft materials. Everything for Concorde is with heat added. So electrical furnaces are wrapped around test specimens to simulate the structural heating conditions experienced in supersonic flight. Stringent testing has demonstrated that in this new flight environment, RR-58 has excellent fatigue life characteristics.
Like all Concorde activities, materials testing in Britain and France is dovetailed into a single coordinated program. Investigations in this Farnborough laboratory form one strand in a complex pattern of research.
This is the hydrodynamic tunnel operated by ONERA, the French National Aviation Research Authority. Colored inks injected into the water stream trace the airflow patterns over the Concorde wing at low speed.
The power plants for Concorde were built by Rolls-Royce. New techniques in design had to be administered on these engines. Because the aircraft will fly at supersonic speed, it will become hotter than a normal turbojet. Therefore, many of the components are made from a heat-resistant nickel-based alloy. The engines, because of their enormous power, must be designed to be quieter, and new techniques were evolved in noise control. It was hoped that when Concorde entered service, it would be no noisier than conventional jet liners, a problem that was to rear its head in the not-too-distant future for Concorde. The panels used for supporting high loads in the wings and fuselage are milled out of solid blocks by computerized machinery. For the really hot spots in the nose and engine sections, titanium is used. Titanium is a tough, unyielding metal which is best cut by laser beam. To achieve new degrees of high precision, new welding techniques were used. This involved the use of powerful electron beams. The retractable visor was designed to protect the pilots in the cockpit from the effects of heat at supersonic speeds and was incorporated into a full-scale wooden mock-up.
There is a mock-up for every part of the aircraft. This is the engine variable air intake.
And this is the power plant mock-up, with a dummy engine being winched into position. During development, this job will be done hundreds of times to check that relocating any accessory has not affected engine installation or interfered with its servicing and maintenance.
The Delta fleet was constructed in part at Bristol, with its strong aviation tradition. This was the centre for the British Concorde construction. To link the construction centres of Bristol and Toulouse in France, a guppy is used, an aircraft not unlike a flying whale, which ferried the parts across Europe between the two centres, making Concorde a truly international aircraft in every detail. The British Aircraft Corporation were responsible for making the nose, tail, and part of the fuselage. Aérospatiale of France completed the fuselage section and constructed the wings. In the building of an airliner, hundreds of ongoing modifications are necessary, following tests on their performance. There were over 500 British and French companies involved in building Concorde. The Anglo-French cooperation was no longer just a treaty and a promise, but a highly efficient organization linked by air and computer lines. British technicians worked around the clock in France, whilst French technicians were doing the same in England. The language was different, but the plans were identical. A part manufactured in France fits the British Concorde perfectly, as too did the parts made in Britain fit the aircraft engineered in France. In a little over 7 years since the Anglo-French agreement to build Concorde, the designers and engineers took the idea from the drawing board to the first prototypes. 2 prototype Concordes were built, 001, the French version, and 002, the British version. The idea that an aircraft could carry over 100 passengers across the Atlantic in 3 hours at speeds faster than a rifle bullet had seemed inconceivable only a short time before. Now, that dream was to become a reality.
the supersonic transport is going to be built. The question is whether in the years ahead the people of the world will be flying in American supersonic transports or in the transports of other nations. And the question is whether the United States, after starting and stopping this program, after stretching it out, finally decides to go ahead. This has been a very difficult decision in terms of a very spirited debate within the administration and also within the Congress as to the proper priority for funds. I have made the decision that we should go ahead. I have made it first because I want the United States to continue to lead the world in air transport, and it is essential to build this plane if we are to maintain that leadership. I have made this decision also because, in another sense, this means that through this plane, we are going to be able to bring the world closer together in a true physical and time sense. This plane, which will fly at 1,700 miles an hour, will mean that in the year 1978, when it will fly commercially, the prototypes will fly in 1972, but in the year 1978, when it will fly commercially, that Tokyo will be as close to Washington, D.C., as far as hours are concerned, as New York, as London is today. And in another sense, that Argentina will be as close, the furthest tip of Latin America, to Washington, D.C., as London is today. This is a massive stride forward in the field of transport, and I think all of us want the United States to move forward in this area.
A nation that had previously led the world in civil aviation, the United States, had been in deliberation over whether or not to commit the funds necessary to build a supersonic airliner. Not wanting to be outdone by the British and French, they too decided to embark on such a program, with Boeing. A design competition was held by the Federal Aviation Authority, and the Boeing swing wing concept was selected. The Boeing B-2707. Unfortunately, the project soon ran into difficulty, the overall concept proving overambitious and impractical. The aircraft was to be built from a titanium alloy, which was both heavy and expensive. It would carry 300 passengers at a speed of Mach 2.7 over a distance of 3,900 miles. At 318 feet long, it would have been the longest aircraft ever built. The swing wings would have enabled good takeoff and landing performances, but the hinges required for such wings proved far too heavy to be practical. The project was finally killed off by the environmentalist lobby, which rallied against the design with mounting pressure until the project was eventually halted in 1971. Russia shocked the world with a Tupolev 144. In looks, it was very similar to Concorde and was able to carry 121 passengers at Mach 2.3 over a distance of 4,000 miles, a performance which, on paper, was slightly superior to Concorde. The Tu-144, nicknamed Concordski, made her maiden flight on the 3rd of December 1968, 2 months ahead of Concorde. Russia had taken the lead to produce the first supersonic civilian transport, but the basic design was to prove fatally flawed. O01 was ready for its first flight. On the 2nd of March, 1969, the aircraft was rolled out of its hangar at Toulouse to make its debut. The world's press were gathered to see British test pilot Brian Trubshaw take the French Concorde to the air for the very first time, marking the start of a new chapter in the annals of airline history. This was the beginning of a new era, the age of supersonic travel, which would bring countries closer together than ever before. Just over 1 month later, on April the 9th, Brian Trubshaw flew the British Concorde 002 on its maiden voyage from Filton to Fairford.
It went very well. It was a great experience for me, my first trip in the Concorde, and Andrei Turkar was kind enough to let me do the whole flight. He, of course, was in command, but nevertheless, it was very useful experience and difficult for me really to say how valuable it will be in terms of knowing now more about a Concorde when I come to take 002 from Filton to Fairford.
Two months later, both aircraft appeared together at the Paris Air Show. Concorde test pilots, like John Cochrane, owe much to the supersonic test pilots who flew before them. Concorde test aircraft 002 was never to see airline service, but it was used to fly to its absolute limits in all kinds of weather. 002 was to become the most tested civil aircraft ever. Every day, the Concorde was rolled out to take to the air from its British or French base. 002 was prepared for takeoff. Radar tracking stations and standby airfields had been alerted. The prototype was loaded with 12 tons of electronic gear and 80 tons of fuel. O02 climbs on full power into her natural element. The prototype engines belch out smoke, but the production engines were to be much cleaner and quieter. With heat and nose shield raised, Concorde takes on the profile of a rifle bullet to fly beyond the speed of sound. As Cochrane takes the aircraft through the sound barrier, the shock waves of supersonic flight are dispersed high over the sea. At 30,000 feet, Cochrane cuts an engine. Automatic systems take over, and 002 continues to climb. As the aircraft reaches 1,400 miles per hour, it's flying itself. The controls and systems have been highly developed and are assisted by computers with automatic reflexes. Because of this, an experienced airline pilot could be trained, if necessary, to fly Concorde in just a few hours. Airline captains were allowed to fly the early prototype and found it a safe and simple aircraft to fly. At 40,000 feet, the outside air temperature is well below zero, but Concorde's skin is hot enough to fry an egg. This is the heat barrier. At these speeds, the plane is heated by the friction of the rushing air. Leading edges reach temperatures in excess of 100 degrees centigrade, but the new alloys have conquered this problem, and they stand up well to the extreme heat. Concorde cruises twice as high as Mount Everest. The onboard radar maps a flight path up to 300 miles ahead. At these heights, Concorde comes into its own. Concorde is the first airliner to spend most of its flying hours on the edge of the stratosphere. On these tests, it carried sophisticated laboratory equipment for research into the upper atmosphere. precise measurements are recorded to establish that Concorde would not harm this rarefied environment. Each trip produced a mass of detailed information which was then processed and stored at the flight test centers as a complete record of the aircraft's development. At these altitudes, tests have shown that engine pollutants are infinitesimal and that Concorde's condensation trail is almost pure water. The flight crew were just the first rank of a huge army of designers and technicians. They were the elite of the French and British labor force working on the project. With another test flight over, a few more hours had been removed from the planned 4,000 hours flying test time. Ground crew close in to examine every point of 002. The aircraft would be prepared in just a few hours for another test flight. The flight recorders would have been reloaded. The recorded tapes from the previous flight were analyzed. The computers, however, could not tell the whole story. Cochrane and his crew will have to describe in full detail how well the aircraft handled under the varied conditions. The crew's seat-of-the-pants judgment was just as important as the computerized information was to the test society. Toulouse, France. The first production Concorde was officially unveiled. It had been built across frontiers of language and tradition, giving Europe an industry of continental scale. Concorde was scheduled to go into regular service in 1975. BOAC were the first to order. They signed an agreement to buy the first 5 Concordes, which they will use to fly an express service worldwide. Air France soon followed suit. China also placed orders for the supersonic bird.
The fast line is Concorde. The slow one is one of today's jets. From New York to Rio de Janeiro, cut from 10 hours to 6 1/4. Los Angeles to Tokyo shows an even more dramatic saving. More of the route is over ocean, so more can be flown supersonic, cutting today's 13 hours to 6 hours and 15 minutes. Take two spots on opposite sides of the globe. Sydney, Australia, and Paris, France are nearly as far apart as you can get. In a modern subsonic, the journey should take 28 hours and 40 minutes, and those last 40 minutes must seem like forever. In Concorde, the journey will be slashed to 15 hours. Suddenly, no two places will be more than 15 hours apart.
In the summer of 1972, Concorde flew across the world. Athens. When the legendary Icarus flew too near to the sun, it melted the wax which fixed the feathers to his arms, and he fell to his death. The heat remains, but it didn't bother Concorde when it arrived on the first leg of the demonstration tour. Beirut, an important crossroads for the world's airlines. The Concorde builders were looking for orders. Building this aircraft had taken enormous resources from both governments and industry. The sales tour took the aircraft to Iran. A supersonic airliner based in Tehran can dramatically shorten the historic routes between Europe and Asia. On this tour, Iran gave preliminary orders for 2 aircraft. India was the next stage of the tour. Thousands of miles away from its base, Concorde proved to be a reliable aircraft in all climates. In the Far East, on the other side of the world, life travels at a traditional pace. Fast turnaround is essential if a supersonic airliner is to reach peak efficiency in airline service. Checks were completed in less than 45 minutes. Concorde had been specifically designed for use at airports anywhere around the world. On this demonstration tour, Concorde slipped into the regular flight pattern of the airport with the minimum of difficulty. From Europe to Singapore would take just 12 hours by supersonic express. This could mean that this great Asian port could become the center for Far Eastern supersonic flight. This idea interested the Prime Minister of Singapore, Lee Kuan Yew. The tour then went on to Tokyo. In the industrial capital of the Far East, the Japanese businessmen were very interested in Concorde. Japan's industrial links with Europe and the USA were growing fast. Supersonic travel could help those links grow even faster. The final stage of the tour took Concorde to Sydney, 13,000 miles from its base. To reach Sydney by Concorde from London would take half a day. For the first time in airline history, circumnavigating the Earth in 24 hours had become a reality. At the Paris Air Show, Concorde appeared to make its usual demonstration, accompanied by the second prototype of the Tu-144. This new design exhibited many radical changes. It now had forward retractable canard wings to help it at subsonic speeds, and the engines were now spaced further apart. This was to be a tragic day for the Soviet team. Whilst going through its display routine, the aircraft climbed and then dived. During the dive, it appeared to suffer problems. Although it has never been ascertained as to exactly what happened. The pilot, M.K. Kuzlov, had appeared to try and pull out of the dive to avoid a Mirage jet fighter, then another dive and pull up again. On the last maneuver, the aircraft lost a wing and broke apart, plummeting to Earth. 14 people were killed in the disaster, including all 6 on board the aircraft. The debris and carnage spread for miles around the northern Paris suburb of Goussainville. Although it was not directly connected with the Soviet crash, Concorde suffered severe setbacks during 1973. Daunted by the high running costs and the lack of profitability in carrying 100 passengers, when a jumbo carried over 400, many of the world's airlines dragged their heels and cancelled preliminary orders. Pan Am, Qantas, Japan Airlines and TWA all backed out of buying. It now seemed likely that no more Concordes would be sold beyond the ones to Air France and BOAC. In December 1975, the Tu-144 entered service between Moscow and Almaty as a mail and freight transport plane. There were unconfirmed reports of another accident, but the exact details were cloaked in secrecy. By 1985, the Tupolev 144 was out of service. At the end of its long service as a test aircraft for the production Concordes, the prototype 001 is flown for the last time. With Brian Trubshaw at the controls, the aircraft lands at Duxford Airfield in Cambridgeshire. 001 is being retired. It will never carry a fare-paying passenger. 002 had already been retired, first to a museum in France, and then to the Science Museum at Yeovilton Royal Naval Air Station. For Brian Trubshaw, this was a sad day, along with many others.
This aeroplane could have been used, or should have been used, for sort of general research purposes, but other people thought otherwise. And in those circumstances, we all feel, John Cochrane and myself and people who've flown the aeroplane a lot, that it couldn't possibly have come to a better place than Duxford.
In 1976, Concorde made another milestone when it entered into airline service for the very first time. Concorde 206 was making its maiden flight from Heathrow to Bahrain as the start of a regular service between the two cities. The world's press were on board to record the historic event, along with many British dignitaries and veteran airmen.
Countdown over, the brakes are released, we start to roll. Thousands who have come to watch flash by, and we have liftoff. Passengers, led by the Trade Secretary, Mr. Shaw on the right, Mr. Henry Marking of British Airways, and the Duke of Kent, have a chance at last to weigh it all up. Concorde is a bit short on headroom at the sides, and the aisles are narrow, but the seats are wider than a conventional aircraft's tourist class, and there's more legroom. For the first hour and 20 minutes, Concorde was subsonic, but after crossing the Alps and sweeping towards the Adriatic, the final checks before the big acceleration. A slight sensation as the reheat is turned on, then through Mach 1 and onto Mach 2, the muzzle velocity of a rifle bullet.
There it is. Ladies and gentlemen, this is the captain. As you notice, we're coming up to twice the speed of sound.
Well, we've had the most excellent supersonic lunch, and we couldn't be more comfortable, and it's the most tremendous and very exciting experience.
It's been a wonderful experience. I think that thrust through to supersonic, I've never been through that before. Somehow you sort of feel the aeroplane needs it. It knows where it's going, and I feel we need to know where we're going. It's been a lovely experience.
It's wonderful. Absolutely super. Something I'd always dreamed about and never thought I'd do it at the age of 75, and I'm jolly proud to be British and feel we and the French have done it. I can't say more. I can see nothing wrong with it. Super, fast, elegant, streamlined, perfect service. Well, nothing more.
Concorde touched down at Bahrain after its very first scheduled flight in airline service. Although the aircraft had been welcomed in the Middle East, in the United States, it had been a different story. There had been a great deal of controversy and debate as to whether or not it should be allowed to land there. Against much opposition, the mayor of New York finally allowed Concorde to land at Kennedy Airport on a trial basis.
After careful deliberation, I have decided, for the reasons set forth in detail in the opinion, to permit British Airways and Air France to conduct limited scheduled commercial flights into the United States for a trial period not to exceed 16 months under certain precise limitations and restrictions.
Today was the biggest gathering of protest groups since the announcement the federal government would allow Concorde to land at Kennedy Airport. They want the Anglo-French SST banned from New York, saying it's too loud and potentially damaging to the environment. One of the biggest protest groups gathered in Howard Beach, forming a motorcade to the airport. Brian Levinson organized it.
We don't want to live with the existing noise. We're sick and tired of presidents and governors and mayors sitting on the fence and not representing us properly. We want to show them that 500,000 people is an awful lot of people.
My house is noisy enough as it is without this coming over it. We don't want the glasses to be broken and everything else. We have a right to live. Let them send that plane back to France.
It's a bomb. It's a hazard, and this government shouldn't put up with it.
We don't need it. We're not going to have it. Period.
I can't afford to go back to England back and forth. This is only for the rich people. What about the common people?
The organizers of today's demonstration say what they plan on doing is to slow down the traffic at Kennedy Airport by using this car caravan going at 5 to 10 miles an hour around the airport. But that following that, they say they plan on other demonstrations. They say stronger demonstrations that they hope will stop traffic throughout the airport unless the SST is stopped. They moved on the airport at a snail's pace, caravans of cars with their lights on, bound for the terminals of British Airways and Air France, the airlines that fly the Concorde. Some protesters deliberately stalled their cars, snarling traffic even more. They say Kennedy is unlike the other airport where the SST's been approved, Dulles Airport in Washington. Protesters say Dulles is surrounded by open land and few homes, but complain that planes approaching Kennedy fly directly over sprawling residential areas. The protesters say they hope demonstrations like this traffic tie-up will prompt the Port Authority to deny the Concorde landing rights, but the PA hasn't given any indication yet how it will decide or when. Dave Monsees, Channel 2 News.
In the interest of fair play, the people who make the Concorde present both sides of the question of a trial period for Concorde service at Kennedy Airport.
I'm against the Concorde. I've lived in the area for 7 years, and I've watched the air traffic in the area grow tremendously to the point where you can't have a sustained conversation for more than a minute without stopping because of an overhead airplane. I understand that plane traffic is essential, but the Concorde is going to serve a very small elite group of people, which is going to inconvenience far more people on the ground.
I think the Concorde should be allowed to land at Kennedy Airport for several reasons. Now, a lot of people are under the impression that it's going to come in at a supersonic speed, but it's not. It's going to land just like any other plane. Other people say it's going to be quieter than the normal planes now. I don't believe that either. I think we should let it land and see for ourselves how it's going to be. We don't have to answer to anybody. Let's just listen to it and then see how it goes from there.
The go-ahead had been given for Concorde to land at Kennedy, and there was no shortage of passengers waiting to make the first scheduled flight to New York from London. And in France, the story was exactly the same. British Airways and Air France were starting their scheduled service on the same day.
Yes, I think we all feel very excited. We're very proud to be involved. It's a great day in the history of aviation, British Airways and Concorde.
Are there any special problems in flying into New York?
No, none that we haven't or can't overcome. We reckon we've seen right through the whole picture now, and we're ready to start.
What sort of reception do you expect?
I would think fairly low key. I don't anticipate any great antipathy towards us or the aeroplane at all. The proving flights were conclusive.
What about the noise levels, which the local communities have complained about so bitterly and so long?
Well, they were based on either lack of knowledge or incorrect information. The proving flights were absolutely clear-cut in their proof that we could meet the noise requirements, both in terms of the black boxes and also community attitudes, and we intend really to continue from there.
Do you feel that Concorde is going to be a commercial success on this route?
I'm quite certain it is. It's full today, and it'll be full most, if not every day.
This flight was Concorde's biggest step forward. Bahrain put it into service, Washington got it into America. But New York, with its huge volume of traffic, is the route for which it was designed. And incidentally, a route which Europe, with Concorde and the Laker Skytrain, can now claim to have revolutionized. All inaugurals are festive as well as historic occasions, and this, in Concorde's impeccable style, was no exception. Champagne served at twice the speed of sound, New York hurtling nearer at the speed of a cannon shell, the sun losing the race to keep up with Concorde, the ultimate in conventional flying machines.
But however long ago it was designed and however many hours one spent talking about it, to actually be up here flying it across, it's very difficult for me to accept that it can fly this distance in 3 hours and 20 minutes odd. We're sitting up here now at 11 miles high, 55,000 feet. We're traveling at 1,350 miles an hour, which is 10% faster than a rifle bullet, and we're 2/3 of the way into what must be one of the most important flights that Concorde's ever made.
On the ground, a small group of demonstrators were out to protest once again about Concorde landings. But their numbers were small, and their appeals to airport workers not to cross the picket lines were ignored. So, despite all the opposition, Europe was suddenly 4 hours closer to New York as Air France made the first historic landing of a supersonic commercial flight at Kennedy Airport. One minute, 30 seconds later, the British Concorde was brought in by Captain Walpole for another perfect touchdown. 45,000 people have already flown Concorde with British Airways, but those on today's flight had made perhaps the most significant journey of all. The two jets taxied together for 300 yards across the airfield before peeling off to their respective terminals. And supersonic transport for fare-paying passengers had finally arrived at New York. British Airways, in the words of their deputy chairman, had taken their first real bite of the Big Apple.
In 1919, Aycock and Brown became the first men to fly the Atlantic non-stop. It was a long and exhausting feat. 60 years later, Concorde completes the journey in only 3 hours. The story of Concorde is a story of survival. Many times it came close to extinction, but it survived, thanks to the dedication, faith, and belief of those who controlled its destiny. For Great Britain and France, it is a mark of sheer excellence.